All right, so some of this is a repeat from yesterday, so I'm just going to kind of skim over it. I started editing the notes and taking stuff out, but it was still going to take 2 pages, so it wasn't worth trying to cram everything together. So this just talks about compositions again. But then here's kind of where the new stuff comes in. So it does tell you again about how compositions of functions work, and that that's different ways to write it. But then here is where the new stuff comes in, the domain. The domain of f of g of x. It is the set of all x's in the domain of g, okay, such that g of x, now does g of x represent x or y? Y. Such that these y values are in the domain of f, and domain represents what? X. So we already know for a composition, you have an input, then you get an output, and then that output becomes the input, right? And so what we're doing here is we are restricting the outputs of G so that they are in the domain of F. And we look at this, and it's not always, they're not always called F and G. They can be called other things, right? And even if they are F and G, it's not always F of G of X. It could be G of F of X. But basically, this is saying that the X values on the first one, and then the y values on the first one, and then the domain of the second one, that type of thing, inside out. Okay, and I'll talk you through that when we get there. But x must be in the domain of g, obviously, and then you get g of x, and g of x must be in the domain of f. And sometimes it's super simple, and sometimes it makes your brain hurt a little bit. Okay, but we'll get through it. Then this goes on to talk about reading and notation. This is the same thing that we talked about yesterday. I don't know that this was on there though. F of g of x, we're not multiplying the two. I think you know that, but just to make sure that we're substituting it in, we're not multiplying the two together. And this, if you see a dot like that, it's different than the little circle. That's why I told you it was a little tiny circle there, not a dot. The dot would still mean that it was multiplication, okay? And how to read it, all that good kind of stuff. So then, let's do composite functions and the commutative property. So we are going to find f of g of x, and we are going to find g of f of x. That's something you should totally be able to do at this point. So make it happen. These are the two answers you should get. If you made a sign error on the second one, shame on you, okay? Because you are not listening when you substitute in really anything, you should put it in parentheses, but especially if it's more than one term, we should not be making mistakes like that again. Hopefully that didn't happen, but I highly doubt I'm going to go through all day and somebody doesn't do it. All right, so this says, can you determine whether the composition of functions is commutative? Commutative means that you can put it in either way. So are these exactly the same answers? No, and we did look at one of these like that yesterday. So we can say, to answer this question, the composition is not commutative. And what that means is that f of g of x does not equal g of f of x. Now, is it possible that we could get the same answer out? Sure. I mean, it could happen depending on what the equations are, but it's definitely not a hard and fast rule. It would be a coincidence of some sort. Okay? What questions? Or they would be inverses, but we'll get to that. We good? Any questions? Okay. Let's flip this over. Now we're going to get into looking at the domains of these, because we're going to find the rule, which we've already been doing, but then we're also going to look at the domain. So the first thing we're going to do is look at the domain of all the little functions that we start with. So for f of x, which is x squared minus 3x, what is this domain? Oof. Yes, very good. Because what is this going to graph? A parabola, which means it is all real numbers, so it is negative infinity to infinity. Very good. I act like that was the hardest question in the world. It scared me a little bit. Okay, so then let's look at g of x for the domain. What can x not be? Negative 2. So my domain here goes from negative infinity to negative 2, and then from negative 2 to infinity. All right, and then what about square root of x? What's my domain here? Well, okay, then figure out what your domain is not. What can x not be? Negative. So how do I write that as a domain? 0 to positive infinity. Good. Do I get to include the 0? What's the square root of 0? 0. So I'm good. Right? Okay. Everybody get with those domains? Little things that we need to know, right? Okay, so then let's find f of g of x. So I'm going to take g of x, put it in f of x. So this is going to give me 1 over x plus 2 squared minus 3 times 1 over x plus 2. Right? So I take this first one, and I'm going to square it. And when I do, that can just give me 1 over x plus 2 squared. A little bit nicer way to write that. Then minus, and when I multiply that, that's going to give me 3 over x plus 2. Now I have two fractions. I need to put them into one fraction, which means I need a common denominator. What would my common denominator be? X plus 2 squared. Good. So if my common denominator is x plus 2 squared, then the first numerator is fine like it is, right? But then this fraction, I have to multiply by x plus 2 over x plus 2. So that's going to be minus 3 times x plus 2. Everybody with me? Okay. And then that is equal to, so my denominator is still x plus 2 squared. So that when I distribute that negative 3, that's going to give me a negative 3x, and then it's going to be minus 6, but I have a plus 1, so it's minus 5. So this is f of g of x. Now I want the domain of this. This is how I look at the domain. It's the domain of g, which is this right here, such that the outputs of such that g of x, which are the outputs, live in this domain. Okay, so with that rational, is there any x that I could substitute in where I wouldn't get a real number out? right? I'm going to get real numbers no matter what I put in, right? I mean, my domain is restricted, but my outputs could be all real numbers. You agree with that? Okay. So then or at least not all, necessarily all real numbers, but it lives in all real numbers. Whatever my outputs are, they're going to have to be a real number. It's not, the outputs are not all real numbers, but which means that my domain is just negative infinity to negative 2, and then negative 2 to infinity, which in this particular case is the same domain as what you see here. It's not always the exact same domain of what you see there. That's why we have to take into account the rule. Okay? Sometimes it's that easy, and I could have just looked at that, but that's not how it always works. Okay? What questions you got? Okay. So now let's look at g of f of x. Right? So g of f of x. And let's put that in here. So f of x is going in g of x. So this is going to be equal to 1 over, instead of x, I get x squared minus 3x, and then plus 2. Right? 2 terms, so I'm definitely putting it in parentheses. In this case, the parentheses really didn't do anything for me. So this is just 1 over x squared minus 3x plus 2. It is always going to be very helpful if we factor. So when I factor this, I'm going to get x, and what are my two numbers? Negative 1 and negative 2. All right, so the domain of f, it's the domain of f. This is the domain of f, such that the outputs all live in the domain of g, okay, which they do, because my outputs are going to be real numbers as well, right? And so then that's my domain, except that I need to also take into account this domain here, okay? So this domain here is going to be, what can x not be here? 1 and 2. So negative infinity to what? 1, and then 1 to 2, and then 2 to infinity, okay? So my domain is the domain of f, which is all real numbers, such that the outputs live in g, which they do, but then we also have to take into account what's happening here. Okay? What questions do you have? All right. I move this thing again, and I don't know how I move it. I can never move it back. All right. Let's look at f, or at c, rather. So here I'm going to find f of h of x. So I take h of x and I put it into f of x. So this is going to give me the square root of x squared minus 3 times the square root of x. Okay? Everybody okay with that? So what is the square root of x squared? X. So I get x minus 3 times the square root of x. That is f of h of x. So the way I look at my domain. So when I look up here, my domain is the domain of h. It's the inside. Domain of h, which is this right here, so long as the outputs live inside the domain of f. The domain of f is all real numbers, so my outputs from h should live in all real numbers, right? Which tells me that that is my domain unless I need to take anything else into account. Are there any other restrictions on this? This is still, because of that square root, it's still the same, right? Oh, Lord. And then there's no extra restrictions. So my domain just is the same as that, which is 0 to infinity. Okay. Everybody okay with that? All right, so now let's find h of f of x. So h of f of x, I'm going to take f of x, put it in h of x. That is the square root of x squared minus 3x. Can I do anything else to simplify that? Nope. So that is equal to h of f of x. That's all I can do. Just plug it in, and then that's it. All right? All right, so my domain is the domain of f so long as all of the outputs live in the domain of h, right? Now this one, I think it helps if you have a picture, okay? So we have this function, x squared minus 3x, okay? And we want to think about the outputs of x squared minus 3x. So we want to look at the graph of that. We know it's a parabola, right? If I have x squared minus 3x equals 0, then x times x minus 3 equals 0. So where does this parabola cross the x-axis? At 0 and at 3, right? Those are my zeros. And it opens up, so I know that it looks like this. You with me on that? So blue curve, the parabola I just drew, that is the output of f of x, yes? So the outputs become the inputs. So my outputs are here and here that would actually fit in that domain, right? Because the domain says that x has to be greater than 0. This is where the outputs are greater than 0. Now that's where y is greater than 0, right? But aren't those y's about to become my x's because they become inputs? Right? So these outputs have to live in that domain. I have to be able to substitute them in there. So there are my outputs that are greater than 0, and that becomes the domain of my function, which tells me that my domain goes from negative infinity to 0, and then from 3 to infinity. Because yes, these are y values, but my y values become my x values. That's why that becomes the domain. Okay? And you see how sometimes the graph helps a little bit better to wrap your mind around it than just the equations. What questions do you have? Any questions at all? All right, good deal. Okay, let's use the graphs of f and g. Gingerbread men just have an attitude today. All right, f of g of 3. We are using the graphs again. So f of g of 3. Okay, so what is g of 3? 1, right? G of 3 is 1. And then f of 1 is 2. So my answer is 2. Equals 2. All right, then f of g of 1, so g of 1, what is g of 1? 3. Then we want f of 3. What is f of 3? 2. So then my answer is 2. Any questions about any of that? All right. So then I have f of g of 4 times g of f of 1. So let's find g of 4. What is g of 4? G of 4 is 0, right? Then f of 4, oh, not f of 4, goodness, f of what? 0. What is f of 0? 4. Okay. Then I need to do this part here, so I need f of 1. What is f of 1? 2. And then g of 2 is 2. Okay. So what I'm trying to do here, I'm taking those two, I'm going to multiply them. So that's going to be 4 times 2, which is 8. All right. Now I'm going to need to find all of this stuff here. So let's find f of negative 1. What is f of negative 1? 6. Then I need to find g of 3. G of 3 is 1. And then f of 1 is 2. Okay. So when I do this up here, f of negative 1 is 6. What is f of g of 3? 2. So then my answer is 3. Okay. Everybody good with all that in the process? Okay. Good. Then f of g of 4. Y'all go ahead and do these last two because they're just back to being crazy simple. We'll double check ourselves. I'll agree with that. I'll double check myself. I didn't get any better yesterday as the day went on. I was still writing wrong things and doing wrong math. So on the easy stuff, not on the hard stuff. All right. Any questions about any of that? We understand how to use all those pieces? Yes? Beautiful. All right. Grab your next piece of paper. This is going on page 66 as well. We're going to look at decomposing functions, okay? Instead of putting them together, we're going to take them apart. This is an important concept to understand, very important when you get into calculus so that you can actually do the chain rule correctly, because if you don't recognize that you have a function inside of another function, then you don't even know to do the chain rule, and that is a big sticking point sometimes. All right, so there are more than one answer to a lot of these, and we will talk about that a little bit more when we get to example 5. But let's just kind of leave this kind of simple and basic. I think that there's one way that's kind of always a little bit easier for everybody to recognize. And so when I look at A, and this is h of x. So if h of x is going to equal f of g of x, the g of x is the inside part here. So if I look here, this inside part is x plus 3. So if I say g of x equals x plus 3, what do you think f of x would have to be? X squared. Okay? Because if I'm going to do f of g of x, that means I take g of x and I substitute it into f of x, and I should get h of x there. You see how you just undo that? So the easiest way to do it is if you can make that if you can make the outside a parent function of some sort, then you can go that way, right? So let's look at B. What do you think the inside would be? X minus 5. And if that's the case, then what would f of x be? 1 over x, good, which is also a parent function. So then C, what do you think our inside is? X plus 2, good. Then what would f of x be? The square root of x. You understand how that works? Taking them apart there? All right, so all three of these give us a parent function for f of x. That's not going to happen in D, but that's fine. What do you think your inside would be? X minus 2, good. X minus 2, which would mean your f of x would be what? Very good. X squared minus 4x plus 5. And then I think you can see how you would substitute it in there and get that, right? Any questions at all? So if we go the other direction, if you want to find f of g of x, you are going to take, if I take g of x and substitute it in here, I get this. If I take x minus 5 and I substitute it in right there, you get that. We're going backwards, okay? Does that help? Okay. Anybody else? Thank you for saying something. We good? Okay. So now we're going to look at example 5, and we're going to do this one 3 different ways. So let's start by writing f of, what was I going to write? Yeah. H of x equals f of g of x. So let's write that down 3 times. I know it says 2 different ways, but we're going to do 3 because we're special. F of g of x. And then h of, so I'm writing down the exact same thing. And then underneath each one of those, I'm going to write down the exact same thing, which is g of x equals, and I'll tell you why I'm having you write all this stuff first. Now, you can write down either one you want first. I think it makes the most sense to write down g of x first, just because you can kind of pick the inside there. So just basically make 3 little things like this. All right. So I want everybody to just go ahead and fill in the first one with a g of x and an f of x. Okay. And then I want somebody to be brave enough to volunteer to give me their 2 functions. Anybody? Yeah, for the first one. Say that one more time. For g of x? Okay. Sorry, I thought you said 3x plus 1. That's why I had you repeat it. All right, and what's f of x? Square root of x. Good. Okay. Does everybody agree with that? Yes. Did anybody write anything down differently for their first one? Okay, so now I want you to think about it. I want you to write down a different one than that. And I want all of your f of x's all need to have a square root in them. No fair just saying that it's x and you get to put the whole thing in. You understand? Like I could say g of x is the square root of 3x squared plus 1, and then that means f of x equal to x. That's kind of cheating, and that doesn't count. What you got? Okay. X plus 1. Okay. What do y'all think of that one? Does that work? Absolutely, 100% good. So if you don't have that one written down, write that one down. And then did anybody write something different than that? Okay, so then I want y'all to think about it for a minute. Come up with what you got. Just 3x? Okay. 3x, and then what? X squared plus 1. Does that work? Why not? Yeah, because when you substitute this in, you would put it in parentheses, you'd have to square it, though, right? So that would actually give me 9x squared plus 1, and I wouldn't get the same thing back. You with me on that? It's okay. Thank you for trying. All right? It's okay. So that's why we're doing this, because I expect to get that answer, honestly. Anybody come up with anything different? Go the other way. Or what? It wouldn't just be 3, because if I put 3 in there, then I would just have 3 plus 1 when I did that? Does that make sense? So that's a good thought. What else could I put in? What? Just x squared? 3x plus 1? Would that work? That works. I agree with that. And I think that's what you were trying to do, is kind of adjust his a little bit. So good thought there. Okay. So here's the deal. You may be asked for just one. You may be asked for multiple ones. Honestly, here we were only asked for 2, but I wanted to talk about 3. But chances are even better that it would be multiple choice. So you would at least have to know whether or not they work. You with me on that? What questions do we have? Anything? All right, let's talk about Jim. Jim here plants wheat on his farm in Kansas. The function W of A gives the amount of wheat in bushels that he expects to harvest if he plants wheat on A acres of land. When the wheat is harvested, Jim can calculate the amount of money M in dollars that he will earn from selling he's going to sell W bushels of wheat with this function. Okay? So we are going to interpret the meaning of what Jim has going on here. So we're going to explain the meaning of W of 5 equals 275. So what does the 5 represent? Five represents acres of land, because that's the A, it's acres of land. So this is acres. 275 represents what? Bushels. Okay? So we could say something to the effect of, when Jim plants 5 acres of wheat, he should harvest 275 bushels. Anybody know how much a bushel is? I don't, so I'm just wondering if maybe somebody knew. It's a big basket of something. It's what I picture in my head. I couldn't honestly tell you how big an acre is either, but all right, so does that make sense? Would you have to word it exactly like that? No, but it needs to say basically that kind of stuff, right? All right, so then let's look at B. M of 65 equals 550. What does the 65 represent? Bushels, okay? So 65 is bushels. Bushels. And, ooh, I can't spell. And what does the 550 represent? Yeah, dollars. Okay? So go ahead and write out a sentence for old Jim here. So I said when Jim sells 65 bushels of wheat, he should earn $550. Could I have said that Jim will earn $550 if he sells 65 bushels of wheat? Right? I could have said it that way. Make sure you don't just say bushels. You have to say bushels of something, right? I just said bushels right here because I had already stated wheat. So just make sure that you're clear on what you're saying. Any questions about what you may or may not have written? We're all good. You at least basically say that. We're fine. Okay. So explain the meaning of M of W of 4. Okay, so what does the 4 represent? Acres. And what does the 2100 represent? Dollars, right? Okay, so go ahead and write something out for that one. Let's see it, and then we'll check ourselves here. Okay. So I said when Jim plants 4 acres of wheat, he should earn $2,100. Okay, or you could say it differently, but you can't just say 4 acres. Like 4 acres of what? 4 acres of corn? 4 acres of strawberries? I don't know. 4 acres of wheat, he should earn $2,100. Any questions on any of that? We good? Okay. So we still need to do the back, which will go pretty quickly on Monday. So you can go ahead and just put that away because we're about to run out of time. And I will give you your assignment.